Hi and welcome to this video. My name is Jan-Hendrik and in this video I would like to go into data structures again, since this is the second video out of 2 videos about data structures. And explicitly I would like to talk about data frames and how to import data from Excel or CSV files into data frames in R. For this video I planned the following. So, in our first video we learned about variables and matrices and how to combine them. Accordingly, in this video we're going to learn how data frames are composed and how they are combined. Then, since we don't want to type in all our data with a keyboard, we're going to import our data from CSV files. CSV stands for comma-separated values, which is simply a text file with a certain structure, and from Excel files into such a data frame. Then we learn that the data frame is just a number of vectors combined into one structure, and how we get access to those vectors inside the data frame. And then we will see how we can handle data frame, how we can index one cell in this huge table of a data frame, how we slice or cut the data frame, and how we can do filtering just like in Excel. Now let us have a brief repetition about what we have just learned in the first video and how we now add on additional knowledge to that. In our last video we learned about variables. We learned that there are numeric variables storing numbers, that there are character variables storing characters, and so text, and we always have to put text into quotation marks. High comma will also be fine here, so for the US and UK guys. In continental Europe, of course, we use quotation marks. And logical variables, they can only store true and false expressions, and additionally NA. NA, of course, not available or not valid, will always lead to an A whatever you do with it. If you calculate based on that, the result will always be NA. Then there are lists. Lists are rarely used in R. Nevertheless, lists can mix all that. So lists can store a 15, a text, and a true just in one list. That is non-variable. They can be mixed. This is not true for vectors. Vectors, again, must be variable or pure. They can only store numerics like 10, 15, or 20. Or they can only store characters, Jan, Sam, and Eve. Or they can only store logicals like true, false, and an A. The same, of course, is true for matrices. Now, today, we're going to talk about data frames. And data frames are a bit like lists, but they're made of vectors. And those vectors are all of the same length, so that this has a tabular structure, just like an Excel table. And that's why it works together so well with Excel. And each and every column is one vector. So we see Jan, Sam, and Eve, that's one column. We see 186, 193, and 172, so the body height of those persons in meters. We see male, male, and female, the gender of those persons. We see 99, 108, 68, the weight of those persons, and if these persons are sick or not sick or whatsoever, as a logical here. So those vectors. Inside those vectors of course have to be variable again, but you can mix different vectors in one data frame. So that's a data frame, and this is what we call the tidy data format. This is the format we have to put all our statistical data in. So we have the so-called variables in the columns. So this is the variable name, this is the variable height, this is the variable gender, and so on and so forth. And we have the observations in the rows. So the observation Jan is this row. The observation Sam is 193, he's male, he's 108 kilo, and he's not sick. And Eve is 172, she's female, she's 68 kilos, we don't know if she's sick, it's an A. So this is each and every observation has one row. Well, let's go into our studio and let's see how that works out. Okay, I just arrived in our studio and I open up a new script window so that we can start with our data frames. I give all that a beautiful headline, always with 5 hashtags. It's about data frames and data import. So that's our today's headline, and the first thing we should talk about is how to combine a data frame. Okay, since a data frame is just a number of vectors combined to a large tabular structure, we need a few vectors to do so. So I need a vector of names, and I just assign values to this vector of names, and of course I use the C command, stands for combine, to combine the vector. So the name is Jan, the name is Sam, and the name is Eve. And I run this line, and on the right hand side we already see in our environment that this vector has been stored in the memory of the computer. It's a character vector. It has 1 to 3 items. It's Jan, Sam, and Eve. I continue with some further vectors. So the vector height, that will also be combined, but it's numeric, 1.86, that's my height. Sam's height will be 1.93, and Eve's height is 1.72. And I run this one, and now we have another vector, the vector height. It's a numerical vector with 3 items. It's 186, 193, and 172. And I need further vectors. A vector gender. So the vector gender is male, male, and female. And I also run this vector. It's also a character vector, of course. Then I need a vector of weight. I have to combine that one. It's a 110, 108, and 68. I run it, and the vector, if this person is sick, and this will be a logical vector, and a logical vector, as you know, can only have 2 values plus DNA. Those 2 values are true and false. I could now write true and false, or I just write the T, F, and T, and we see on the right hand side the vector is now a logical vector with items 1 to 3. It's true, false, true, true. So you can also always abbreviate true and false using the capital T and using the capital F. Now I make an error. Of course, just to demonstrate that this is an error, I try to combine a data frame that is called data, and I don't use the DataFrame command, but the Cbind command. The Cbind command means column bind and binds another column to a data frame. But if we use it now, here at this place, with all our vectors, and we bind them, and as you see, they're all already proposed here. So after gender comes weight, and after that comes sick, and I just run it. I will now get some data structure here, and we have df data. We have called it df because it's a data frame, and I just want to not to forget that it is a data frame. But we see here something went wrong, because we see now it's a character. It's not a data frame, it's a matrix. It's a matrix with 3 lines and 5 columns, Jan, Sam, Eve, and we see the 186, 193, 172, which is the height in meters, is not shown as a number, but shown as a character. So something went wrong. Using the Cbind command will not lead to that result that we want. But we can improve that situation just by replacing it by data.frame. And I run this one. Accordingly, I override the df data, the wrong structure. And now we see on the right hand side that we have df data. We have 3 observations. Those observations are Jan, Sam, and Eve in 5 variables. And I can click on this little drop-down menu, and here the vectors unfold. This is quite beautiful because I can see what is in the data frame here. So we have a vector of names, we have a vector of height, and still they just look like the vectors down here, but they are combined in a data frame. Well, can we see this data frame somewhere? Well, I can double click on the data frame here, and here we see the tabular structure, just like in Excel, right? We see the names, 1 column, the height, 1 column, the gender, 1 column, the vector weight, 1 column, and the vector sig, 1 column. We see observation numbers 1 to 3. Beautiful, wonderful. Of course, to combine such a data frame, those vectors have to be of the same length. Otherwise, it wouldn't work out. Well, we can achieve the same, by the way, by using the view command. Attention here, view command is one of a few commands in R that starts with a capital letter. It's the capital V here, and just by running this command, we will have df data in its tabular form, of course. Well, this format that we have just seen, I just rerun it, is called the tidy data format. It's just the format. It is not necessarily tidy now, but it's the tidy data format. And we need all our data always in this tidy data format to run statistical models, to run visualizations, to run whatsoever. We will always have it in a data frame and always in this tidy data format. To have it tidy later on, of course, we need to clean it from NAs, we need to clean it from statistical outliers, and so on. But the first and most important thing is to have it in this data tidy data format in this tabular form as we see it here. Well, okay. Since I don't like the names, vector gender, vector height, are reused as column names here. So the vector names is the column name here. It's also the variable name. Well, do we mix that up? Because in statistics we always speak of variables because they are understood to be random variables. Nevertheless, what we see here are vectors of observations. So if we speak of variables coming from statistics, we mean vectors of observations. So this is a variable name, but it's also a name of a vector. Don't get confused from that. That's an important point here. So, can we replace those names by better names? Of course we can. Let's have a look how we can do that. I just copy this line here. And now I give it names. So the names of those three persons are given by the vector names. The height of those persons is given by the vector height. And by the way, I can put all that underneath each other. So sooner or later, this line will have an end. Gender, weight, and now, of course, we've already gone too far. Sick, and we can't see it. What I can do here is just using the enter. And we get this beautiful structure here. Always set the enter after the comma, by the way. And we get this beautiful structure underneath each other. Very, very well readable. All right, I run this one. And now the DF data has been replaced by vectors, which names are names, height, gender, weight, and sick. So the former vector names like vec gender, vec height are now replaced by beautiful names. Great. Now, what else can we do with those data frames? For example, we can check the structure of the data frame. We use the str command and we give it the name of the data frame. And here we get the structure of the data frame, which is pretty much the same that we see up here. So we see that the data frame is made of 3 observations of 5 variables, not vectors, but it is composed of vectors, of a vector that is called names, Jan, Sam, and Eve, height, 186, and so on and so forth. What else can we do? We can make a summary. And that is beautiful. So, this summary that we see is a very, very simplified descriptive statistics. So, if we have character variables, we see the length of 3, the class is character, and the mode is character. Okay, nothing new. If we see logical, it just counts. There's 1 false and 1 true. But if it is a metric variable, we get the minimum, the first quartile, the median, the mean, the third quartile, and the maximum. Just a little descriptive statistics. That would already be enough for some papers, wouldn't it? Well, of course, we can check the number of rows, n row, number of rows, of DF data, and the number of rows is 3. The number of columns, of course, is 5. Then we can get the column names. The column names is names, height, gender, weight, and sick. And we can also use this to replace the names again I just copy it and I assign to those column names a new vector, just like C. All right. I just gave it variable 1, variable 2, variable 3, and so on. Not so beautiful, and we see here that the names have been replaced. Not the best choice for variable names. Nevertheless, I just wanted to show that this is possible. And I can give the rows names too. So the row names of that data frame are 1, 2, 3. And I can replace those numbers by just assigning a new vector of data to those row names. But here I can use the usual vector names, right? So we had this vector up here, vector names, Jan, Sam, and Eve, and I can give those names to the rows. And let us have a look now. Now the 1, 2, 3 has been replaced by Jan, Sam, and Eve. And the column names, again, variable 1, variable 2, and so on. Not the best choice. Nevertheless, I just wanted to demonstrate how all that works. Okay, let's come to our next headline. Now we have to talk about importing data. I just give it a headline, import. Okay, importing data from CSV and Excel files into a data frame. Shouldn't we tidy up a little? I don't really need this, so I can fold it in, and I want to get rid of all the old data. Here's a little brush. Let's click the brush and the data is gone. So we have a beautiful new, oh, and the console. Just like Control and L, and the console is clean too. Beautiful. Now we can start over. And of course, what data do we want to import? I have just put some data on my Windows desktop here. And here's the CSV and here's the Excel. Both are real estate data. And this is my most favorite data set. I just want to show you the Excel and then I show you the CSV. All right, so here's the Excel. And now this is a data set about 1,000 real estates or housings. And we have an observation number here. I already gave it headlines, just like the vectors. Vec observation, vec type, vec luxury, and so on and so forth. And here we have observation numbers. Here we have the type of the real estate or the housing. We have 3 types. We have house, which is a solo house here. We have an attached house, and we have a flat or an apartment. Then we have a luxury. If it's a luxury housing or not, some of them are luxury, some of them are normal. Then we have the size of the housing. It's in square meters. Then we have the distance to the center of the town in kilometers. So this house is 5.53 kilometers from the center away, the distance. Then we have if it's a university town or if there's no university available. It's in German here, wahr, falsch, true and false, of course. Then we have the price, the offering price or the actual selling price, and we have if the housing is sold or not. again, German, true and false, wahr und falsch, true and false. Now, what is the difference with the CSV file? Of course, if I now double click the CSV file, Excel will open too, because Windows recommends to open those CSV separated value files in Excel. Nevertheless, we can right click it and open with, and I choose the editor. And here we see the structure of this file. It's just a text file. That's it. And we see that we have the same structure as in the Excel file. In the first line, we have all the column names, and then we have observation after observation in the rows. And in the columns, of course, we have 1, 2, 3, 4, 5. We have house, house, house attached, and so on and so forth. It's the same structure than the Excel file. But, of course, there is a separation. That's why it's called comma separated file or comma separated value file. Here it's not a comma. Here it's a semicolon. Nevertheless, that will work out later on, even if it's semicolon separated and not comma separated. Let's go and have a try in our studio. So, the first thing that we need is a path to this file. Paths are not very handy to work with. So what I typically do is I set a variable path. I assign it a value, and typically I should now write something like C colon, double slash, something like that. But I don't really like to do that. So what I do is to use the file.choose command, brackets open and brackets close. And if I run this line, somewhere hidden on my other screen is an open dialog. And this open dialog can now be used to go to the desktop and find the real estate CSV file and to open it. Now, the CSV file is not yet opened. The only thing that happened is that the open dialog gave the information, the path information, into this variable path. And here we have the variable path, and here we see CW double slash users double slash Jan-Hendrik Meyer double slash desktop double slash real estate.csv. So the path information is now stored in this variable. I don't have to write it. It makes my life a lot easier. Now I want to read in the data. And of course I need a data frame that is called data. And I have to assign it some value. And those values come from the read.table command. And the read.table command, of course, now needs the path. So I give the variable path to this command. This will lead to an error. Error now. Let me have a try. Okay, interesting data, but what is that? What the hell is this? 1002 observations? Wasn't it 1000? In just one variable. Looks curious, looks like this, and of course this is complete nonsense. So seemingly something went wrong, just as I said. This will lead to some kind of error. Why did this lead to an error? First of all, we didn't tell the computer, we didn't tell R, that the first line comprises the names of the columns. So let's add that information, that the header is true. There are headlines in the first row. And what we also didn't tell him is that the separator here is not a comma but a semicolon. So separator is the sep attribute, and we should give it a comma, of course, in quotation marks. Again, high comma for the US or British viewers is also available here, but of course I use quotation marks. I run this line and I have now 1001 observations in 8 variables. I double click it and it looks exactly the same. Let's have a look if it's really 1001. Oh, there's a last line that is not valid. Nevertheless, we are going to remove that later on. Well, and seemingly it worked out fine despite this last row. Well, what can we do with this last row? We can now give df data and assign some value, and we only use complete cases. Only those cases where we don't have any NA. So we're overwriting the DataFrame data, df data, with the DataFrame data, but only the complete cases. But this is not enough yet. We have to do something else. We have to give it, because this will only lead, I will show you, this will only lead to some true and false. So here's some true and false. Only the last one is false here. The last one is not complete. So we have to do something else. And what is very important, and in this video you will learn why this is important, we have to add a comma after this and close the squared brackets. Let's run this line. And now we have tidy data, not only data in the tidy format, but we now have tidy data since we have tidied away the incomplete data here. It's still 1000 out of 8 variables. Now it's fine. The last row has been removed. Beautiful. Now we have data we could work with. The second version, so this of course was from the CSV. The second version of gathering the data is from Excel. Okay, we now do a completely different way so that you directly see how that works out. Because we have here this button, import data set, and we can use the little arrow here and we get a menu. We can import data from text. So the CSV file could also be imported the way I showed now, from text with the base commands, just like we did it, and with readar package. We can have Excel here, and we can also import from several statistical programs like SPSS, SAS, and Stata, all the data files. Now we choose Excel, and in case there is a certain library or package, the readxl package, if this is not yet installed on your computer, you will see that something happens on your screen which does not happen on my screen. That is importing this library, this package to your computer. So don't worry about that. Now I can choose here the file. I can browse the files, and of course I go to the desktop again, and I need there's the real estate XLSX. I open it, and now I see a preview of this data. I see the observations, I see the type, I see the luxury, the square meters, distance to center, universe, and since my Excel was German, here it now comes into false and true and false. Now it is turned into English. The same is true for the logical vector sold. Well, what else can we see here? Of course, we can choose a name here. This is the name of the data frame it should be saved in. I don't like it here. I don't like it like this because, you know, I just put df in front. There is no df. I could put it here if I like. And then you see on the right hand side, we have some code. The code preview. So the code will be done by this menu here. And if I now click tab, the computer replaces real estate by df real estate. Well, we can change that later on. I can choose the Excel sheet. So here's a default and some data. I choose the default. I can give a range, for the range inside the Excel sheet, where to gather the data. I can limit the number of rows, but I don't want to limit it here. Nevertheless, I can limit the number of rows. I can skip the first rows on top. That is quite a good function, because if you do this in your company, often plannings or often data files do not start immediately with the headline. They often have 4 or 5 lines and then comes the data. So you can still skip all that stuff that's on top of that table. NA. How are NAs shown in your data file? Let's have a look if we still have the last line. No, it's gone. But in some files, NAs are not called NA. Sometimes then they are NaN, not a number. Sometimes they are simply -99. Sometimes they're completely different. So how are NAs called in your file? Here I don't have NAs anymore, so fine. Now I can checkmark first row as names. This is what we already know from the CSV file. I can untick it, and then we have the headlines or the column words as a first observation. But of course this is not what we want to have, so we tick it again. Well, and we can choose if the data viewer, so the tab with the tabular form, will be shown. As you see here, the view command is given. I can remove it with this, and I can still leave it in there. But what we should not do is to click the import button now. What we should do is to copy the code preview. You can also use this one here, or just Control and C, copy, and then I go to cancel, and then I introduce this one here. So this code is reconcilable now for everyone who reads your code, and no one has to go through this procedure anymore because it is given here. So we have to start the library, read Excel. This is already done on your computer. And then we are going to read in df real estate. I don't like this name. I just want to have a data. We apply the read Excel command to this path here. And seemingly nothing happens, but this data frame has now been overwritten with the data from the Excel file. And we can view it if we like to. Of course, we have to change the name here too, otherwise we'll run into an error. And there it is. Beautiful. Now, since we now have a huge number of observations, like 1000, and in empirical data or even in company data, you will often have 1 million of data lines. Of course, you can't handle all that data. So how can we get a first impression of all that data? We can use the head command. The head df data. And the head command will give us the first six observations in your file, so that you just get a nice little overview over your data. The same is true for the tail command, but of course here you will not get the first 6, but the last 6 lines of your data file, of your data frame. Again, we can use the summary command. Here's the summary of this real estate file, and we see again that the, for example, the observational number, which does not make any sense, but the square meters are given with the minimum. So the smallest housing here is 10 square meters. That's tiny, isn't it? The first quartile, 71 square meters. The median is 94. The mean is 102. The third quartile is 132. And the largest housing in this database is 225 square meters. And of course, we have just like 604 in non-university cities and 396 in university cities, and so on and so forth. Well, and of course, again, we can use the structure to get a grasp of the structure of this file. And here's the structure again. It's the same that we see here. Well, since I just told you that a data frame is a collection of vectors, the question is now, can we get access to individual vectors? Well, yes, of course we can. So I can put it into this in here, df data, and I just add a $sign. So here's the $sign, and now I get a number of vectors that is available in this data frame. I just choose the type and I run this code, and I get an output of this individual vector. Does it help me? It helps me a lot. Let me show you something. I just make the same with df data $, and I use the square meter. Of course I can output it, but I don't want to output it. I just take the mean. The mean means the arithmetic mean, the average. And I get an average of 102 square meters on our housings in our database. So this is how we can access the individual vectors inside the data frame. So just name them with $, or just append them to the data frame name with $, and then the name of the vector. That's it. Now, looking at this data frame, or at this structure here, I see that I don't like it perfectly, because we see here that the type is a character. House, 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 attached, attached, flat, flat, and so on and so forth. The same is true for the luxury vector. So this is typical nominal or ordinal values and or data. And of course I want to have it stored just like nominal or ordinal data. I want to make it a factor variable. So let me please show you how to do that. Okay, I just want to override, let's say, the luxury vector. So df data $, and now the vector luxury, and that is normal or luxury. Well, it's group. It's a group, and in statistics we call it a group variable. It separates two groups: the normal housings and the luxury housings. So, can we tell R to make the same? Yes, we can. We can make it a factor. So, df data $vec.luxury, and I just overwrite it again with as factor, and then the same. Now, what's this? Always, if you see something that starts with as dot, that's always a type conversion. You can convert one type of variables, vectors, matrices, and so on into another one. Just like numbers that are stored as characters, you can convert them with as numeric. And here I want to convert a character into some factor variable. Let's see what happens if I run this line. And now we see that something happens here in our environment. Vector luxury is now a factor variable with two levels. Two levels, normal or luxury, right? And here we see that is some kind of coded. Nevertheless, it's now a factor variable. I would like to do the same with a type. And here we see that the vector type has now been converted into a factor with three levels, like attached, flat, and house. So we have three levels. This is now nominal data, group data. We have three groups: houses, attached houses, and flats. Of course, we can also order that. So this was nominal data, and now we come to ordered data. And we now want to order that. So I use the command factor. And I use the command factor to dfdata $type. And I give it the attribute ordered is true. Now it has to be ordered. But the computer doesn't know how to order it. It's like cold, medium, warm, or small, middle, large. They're all ordered. Another order wouldn't make any sense. Of course, here we can order like flat, attached, and house, because the house is the largest, the attached is typically medium, and the flat is typically the smallest. Well, so we have to give it an order, since the computer doesn't know how to order. Levels equals, and I give it some vector now, and the vector is now flat, of course, then attached, and then house. And now we see that the computer gave us levels. Flat is smaller than attached, is smaller as house. So now we see that they are ordered. And we can, of course, see the result using, I just type it in here, with using the levels command. And here we see the individual levels: attached, flat, and house. Now we come to our last topic.
I would like to apologize for the rather poor taste of the previous item.
We want to do some data handling. So how can we access the data in this data frame? Let's give it another headline. And of course, let us clean up a little. No, we can't remove the data. We still need it. Okay, so we already have seen how to access an individual vector. That was like df_data, and we use the and then we choose one of those, like distance to center. I can run it. Better would be to use the print command, of course, but I can directly run it and get an output. Well, and this output here is a vector. This is important because some functions want to have a vector. Some other functions want to have a data frame. So you always need to know, what do I hand over to this function? The mean command that we have just seen and that I can apply now here, of course, wants to have a vector. It doesn't want to have a data frame. And now I see that the mean distance from the city center is 3.55 kilometers. I can also access data frames. So returning data frames. I do it like df data, and now I use squared brackets, and I give a 1, like the first column. And I run this. And here we see the first column. And we also see that this is a different structure now than we know it before. I can do the same with the fifth column or whatsoever. This is distance to center. Nevertheless, it comes in a different structure because it's now returning a data frame and not a vector. Well, can we have more columns? Yes, we can. df data, squared brackets, and I now hand over a vector again, a vector with those numbers that I would like to have back. And here we get back a data frame with the first, the second, and the third column. So we can resize a data frame with individual columns using this command. I could store it away now in another data frame, like df data 2 or something like that, store it away to have a differently cut data frame. Very close is like returning a vector. But for that we use double squared brackets and maybe column number 5, and we return a vector here too, but using the column index 5 and not using the name of the vector. Well, that is some preliminary stuff, but now we go into indexing. Indexing means finding one individual cell of the huge data table. Let's choose one of them. I just click here and I want to access this 180.76. Now we see that it is in the second row, and we see that it is in the 1, 2, 3 in the fourth column. So second row, fourth column, 180. I use squared brackets again. Squared brackets, and I hand over the second row and the fourth column. Let's run this, and I get back the 181. I just check if it's correct. Yes, it's rounded, but it's exactly this value given here. Now, if I want to have more than just this value, let's say, just open it again, the first 10 of this column. The first 10 of this column. I just reuse the code. But I don't want to have only 2. I want to have row number 1 to row number 10. So this means from 1 to 10, column 4. And here we get the first 10 columns, given back as a data frame here, of course. Okay, so the next topic, of course, then is slicing, cut. . This is what we call slicing. So I have to amend the headline here, indexing and slicing. Slicing just like a sausage. And the last topic for today is filtering. And filtering is really an important topic. So what can we do? First of all, we need to identify those data sets or those data items that we want to have. Let's say I want to have all the flats. All the flats. And not the attached houses and not the houses. I just want to have the flats. So I can do the following. I access df data $, and I need the type, of course. And I now compare this type using the double equal sign here. Double equal means always comparison between left and right. And I give hand over flat in quotation marks. Now I get back something that seems to be very logical. And it always indicates false, 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 false if it is not a flat. And it indicates true, 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 true if it is a flat. Let's see. 1, 2, 3, 4, 5 false and 1, 2, 3, 4, 5 true. If this is really the case. 1, 2, 3, 4, 5 false. 1, 2, 3, 4, 5 flats. Perfectly correct here. Of course, this is just a logical vector. Let's save this logical vector as a vector that we call filter. And now I have saved this logical vector, false, 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 and so on and so forth, as a logical vector that is called filter. And now I can apply this beautiful filter vector to my data frame. And a comma. This comma is important because just look a bit back here. We needed a comma here too. We had the rows, comma, the columns. And here we define the rows that we want, comma, and all the columns. And using this will lead to a data frame that has only 587 observations because that's only the flats. How can I use this now? Of course, I can now enter into this new data frame here and give back the square meters. So these are the square meters of only the flats. And of course, I can now calculate the mean of the square meters of only the flats. And the flats seemingly have an average, a mean size of 76.4 square meters. Well, of course, I can expand this example, just taking the code. And if I want to have not only the flats, but the flats in university towns, I add an and sign. So I will give another expression here. df data $universe, vector universe equals true. So I will only have the flats in university towns. And how about their size? So here's that, and how about their size? Oh, seemingly very close, 75.34. So there's not a big difference between those flats in non-university towns and those in university towns. Well, that was it about
was
data
different.
frames
Yep,
for today
lousy,
and
but
data
different.
handling. Have fun using this. See you in the next video.